Study Section 6. Measure of skewness and kurtosis. Introduction. A fundamental task in many statistical analyses is to characterize the location and variability of a data set. A further characterization of the data includes skewness and kurtosis. In this study session, you will learn the definition of skewness and kurtosis. You will also learn how to calculate measure of skewness and kurtosis from simple series and grouped data. Learning outcomes for study section 6. At the end of this study session, you should be able to define skewness and kurtosis, calculate measure of skewness and kurtosis from simple series and grouped data, determine whether a set of data is normally distributed, the direction of skewness and the level of peakness, and interpret your result. Define skewness and kurtosis. Skewness is a measure of a symmetry, or more precisely, the lack of symmetry. A distribution or data set is symmetric if it looks the same to the left and right of the center point. For univariate data, x1, x2 to xn, the formula for skewness is for discrete data. Skewness alpha 3 is equal to, for grouped data, alpha 3 is equal to, where x bar is the mean, s is the standard deviation, and n is the number of data points. The skewness for a normal distribution is 0, and any symmetric data should have a skewness near 0. Negative values for the skewness indicate data that are skewed left, and positive values for the skewness indicate data that are skewed right. By skewness to the left, we mean that the left tail is long relative to the right tail. Similarly, skewness to the right means that the right tail is long relative to the left tail. Kurtosis is a measure of whether the data are peaked or flat relative to a normal distribution. That is, data sets with high kurtosis tend to have a distant peak near the mean, decline rather rapidly, and have heavy tails. Data sets with low kurtosis tend to have a flat top near the mean rather than a sharp peak. A uniform distribution would be the extreme case. Kurtosis is the standardized fourth central moment of a distribution. The histogram is an effective graphical technique for showing both the skewness and kurtosis of data set. For univariate data, x1, x2 to xn, the formula for kurtosis is, for discrete data, kurtosis beta 4 is equal to, for group data, beta 4 is equal to, where x bar is the mean, s is the standard deviation, and n is the number of data points. In-text question. Calculating measure of skewness and kurtosis from simple series and grouped data. Excess kurtosis. The kurtosis for a standard normal distribution is 3. For this reason, SS kurtosis is defined as, for discrete data, SS kurtosis K4 is equal to, for grouped data, or K4 is equal to, the standard normal distribution has excess kurtosis of 0. Positive kurtosis indicates a peaked distribution, and negative kurtosis indicates a flat distribution. The kurtosis for a normal distribution is 3. Positive excess kurtosis indicates flatness, long fat tails. Negative kurtosis indicates peakedness. In-text question. Diagram 6.1. Peakness of a distribution. A. Leptocratic. B. Mesocardic, normal. C. Platycardic. Example 6.1. 12 numbers were generated from computer are as follows: 10, 43, 67, 89, 70, 80, 62, 80, 03, 42, 71, 35. A. Obtain the measures of skewness and kurtosis. B. Interpret your result. Solution. Mean is equal to 54.3. S is equal to 27.825. Skewness alpha 3 is equal to minus 0.6147. That is negatively skewed distribution. Kurtosis is equal to 2.0039. SS kurtosis K is equal to beta 4 minus 3 is equal to minus 0.961. That is platycardic. In-text question. Determining whether a set of data is normally distributed, the direction of skewness, and the level of peakness. Given the data below, table 6.2. A. Draw the histogram for the above data. B. Obtain the measure of 1. Skewness, 2. Kurtosis. C. Interpret your result. Solution. Diagram 6.2. Table 6.3. Table 6.3. Summation fxi is equal to 3210. Summation f is equal to 100. X bar is equal to summation fx over summation f is equal to 32.1. Table 6.4. S is equal to 7.316. Skewness is equal to 0.0236. Kurtosis beta 4 is equal to 3.3. SS kurtosis K is equal to beta 4 minus 3 is equal to 0.3. Since skewness is equal to 0.0236, kurtosis is equal to 3.3 and excess kurtosis is equal to 0.3. This implies that the distribution is near normal. The kurtosis indicates a flat peak that is leptocardic. Summary for study section 6. 1. The concept of skewness and kurtosis. 2. How to distinguish between kurtosis and SS kurtosis and their interpretations. 3. Useful examples were given to illustrate the different formulae for their computation. This is the end of study section 6. Thanks for listening.